Now this is an enthalpy question which has a couple of twists to it, but it's basically a straightforward question. We're told that when we dissolve solid zinc sulfate, we get a certain temperature change, and we're told the mass, so that means we can work out how much there is for a mole, and we're also given the heat capacity of the container. So then the second, and that process there is this one here, where this zinc sulfate dissolves into a zinc ion and a sulfate ion. Second one is very similar. We've got zinc sulfate, which is hydrated with 7 waters, and in this one we can represent that by this equation, which breaks into zinc sulfate and 7 waters. Now that we have that, we can kind of get an idea that what we're going to do with this equation is we're going to try and manipulate these equations once we've worked out values for that, and we can either combine them or subtract them, reverse them, whatever we need to do to form this equation up above, and we should be able to calculate this. We just have to take care that we get the enthalpy values right for these two, and then we just rearrange the equation. So if you have a good feeling or general feeling about what you need to do, how you need to go through the question, that's important to start with. So first thing we'll do is we'll look at how to actually do these calculations. Now we'd be expecting to use delta H equals the mass of the water times the specific heat capacity times the temperature change. However, we're not really given information for that, so we can't actually use that, but we are given this very useful piece of information. The heat capacity of the calorimeter is 0.9 kilojoules per degree Celsius. So for every 1 degree change, we'd expect it to take 0.9 kilojoules of energy, and for this we find out it's 0.97. So we just have to multiply 0.97 by 0.9. So having done that, we work out it's 0.873 kilojoules of energy. Now that's for 7.8 grams, that's not for 1 mole. So if we work out how much number of moles that is, we just have to divide that into the energy, and we should have the amount per mole. Okay, so if we do this and work out the number of moles, we find out it's 0.0483. We divide the number of kilojoules by 0.0483, and we get 18.07 kilojoules per mole, and that is a negative because this is energy that has been given out. Okay, and that's the first one that we needed to work out. Now in this one, the temperature actually goes down. It tells, of course, that it's an endothermic reaction, and if we do the simple calculation, we find out at 0.31 degrees it's gone down, and if we multiply that by 0.9, we get 0.279 kilojoules. Now that's for 12.3 grams, but we want to know for 1 mole. So we're going to divide 12.3 by the molar mass of zinc sulfate, which is hydrated. That will give us the number of moles, which we'll then divide into 0.279 kilojoules, and that'll give us the enthalpy for this one, which I'll just do now. Okay, if we do that calculation, we find out that we get 0.0428 moles, and that kind of molar mass is fairly easy to work out. We just had to add 7 lots of water at 18 grams each to 161.5, and we then divided 0.279 kilojoules, which was the energy, and divide it by 0.0428, and that gives us 6.521 kilojoules per mole, and that's a positive. So now we've got those energies, we can have a look at the equations and see what needs to be done with that. Now from here it's just a bit of algebraic manipulation. Now obviously we've got the zinc sulfate on the left, which is where we want it, because that's the same up there, and we want the zinc sulfate that's hydrated to be on the opposite side, so this equation needs to be reversed. And when we reverse that, we'll see that obviously this is going to cancel with this, because they'll end up on opposite sides. I won't bother rewriting it, and that will mean the 7H2O will end up on this side, so we'll end up with that equation. So if we reverse that, it's just a matter of minus 18.01 kilojoules plus a minus 6.521 kilojoules because that's being changed, and that should give us our answer. So, sorry, I did a bit of rounding error there. It's 18.07 plus 6.521, and that equals negative 24.59 kilojoules per mole. Make sure of the sign for that as well. And that's that question answered.